KI for long-term validation enabled digital academic testimonials, a case study. I am Sovik Pan. So this is the degree, digital degree, which is signed digitally. You can see the three signatures at the bottom: registrar, chairman, and chairman board of governors. They just digitally signed using USB tokens and public key cryptography. So why PDF? Because PDF maintains the structure across platforms. You can open in any OS like Linux, open in Windows, any of the platforms, but it remains the structure. Structure isn't altered. And also it is lightweight, so exchanging is very easy. And it also provides authenticity through digital signatures and also integrity. And confidentiality is provided through partial encryption. The PDF is not totally encrypted. If there is an encrypted PDF, the structure is still maintained. So the encryption is done only on the strings and the streams, the main part that contains the contents of the PDF, the thing that you open and you see. This is the structure of the PDF. When you open a notepad, you can see it in like this. So let's go into detail. This is the header, the first part. It consists of two lines. If the first line is the version of the PDF, and the second line consists of the 4 arbitrary codes, which says that it consists of binary characters. The PDF preprocessor needs to parse everything as a binary digits. Next is the body. This contains every object. All the things that we see in the PDF is an object. So like you can see object 60 obj, it's the type is font. So the font is embedded here. You can create your own font and embed in that PDF. Also you can see the object 20, it is of type pages. Like every pages has a head which refers to the page. And the object 10 is catalog, is the root of the PDF. Everything is connected to the root. The third part of the PDF is XREF table. Every object has to be embedded here. Like the first 10 digits that you see in this first 10 digits are the byte offset from the beginning of the file. The second 5 digits are the generation number. These are all zeros because they haven't been changed. If you change an object, this will be incremented by 1. And N means it's in use. If it's F, then it's not in use, and it will not reflect in the PDF. The last part is the trailer. Although it's the last part, the PDF processor goes to this at the very beginning, because it contains the beginning of the XREF table from the byte offset of the XREF table from the beginning of the PDF, that is 888, the root, which is the catalog, which I said 10R, reference to the root, the ID of every PDF, and information to this, the metadata. So now, this is the public infrastructure. I think you have heard enough of this, so let's keep it. This is the details of an X509 certificate as shown by certificate viewer. If you click on a signature on PDF in Acrobat, Adobe Acrobat, you can see a window will pop up like this. This is the end entity certificate. You can see the validity from to and all the uses, digital signature, non-repudiation, email protection. And in the left side, you can see the intermediate CA and the root CA, which is CCA India 2014. Next is the digital signatures in PDF, how signatures are embedded. So when a signature is done on a PDF, there is a separate dictionary. Signature object is created, which contains a dictionary, and there is a specific byte range in which the signature is done. Like the whole of the PDF is not taken in consideration when the hash is computed. Only the parts, like only the from first to the signature dictionary, and the rest of the signature dictionary is taken, except the contents part, which contains the signature, actually. The hash is computed, and the signature and the private key, signature is done using private key, and it is embedded in the contents part. The subfilter contains the algorithm, hash algorithm, which is used to compute the hash, and the signing algorithm, which is used to sign. We'll see it later. Here. These are the algorithms that are used in the subfilter part of the signature dictionary. these two are deprecated as of now because in the latest version of the PDF 2.0, these two are not in use. So these are advised to use Adobe PKCS 7 detached and ETSI CADS detached. These are used, they use SHA-256, SHA-384 and 512 as the hash algorithms, and RSA are used as the signature algorithms. These also support elliptic curve cryptography. The latest ISO standard has adopted the PADES version, which is a set of rules and signature, process of and properties of signing in PDFs. So signatures in PDFs are basically done in serial wise. So the first signature is called certification signature. It can provide you the access, like you have seen that you can add annotations, comments after in a PDF. So if the first one to sign the signature, sign the PDF can restrict you to add a signature, like if or add a comment. Like if you add a comment after he has signed, it will show that there is some error in the signature. So it is called certifying signature, and the rest of the signatures that are done after that are called approval signatures. These signatures take the bytes of all the other signatures that have been done before that as the contents of the PDF itself. Like they don't treat them as signature; they treat as the content of the PDF. So they treat them similar to PDF contents and take the hash of them and sign them. Okay. Okay. So this is the long-term validation. Long-term validation is the information that is required to validate the signature after that is signed, or long after it is signed, and when the certificate is basically expired. If the certificate is expired and long-term validation is not enabled, then the signature after the certificate has been expired will show that it's invalid. So to preserve the integrity of the document and say that the certificate was authentic and valid at the time of signing, so it was we embed long-term validation contents. The document security store and validation related information are the information that we embed in it. So these are embedded: CRL, certificate revocation list, and online certificates as protocol response. For each signature is been embedded in the validation VRI dictionary. This is the GUI of our software that we use for batch signing, the signing of our degrees and other academic testimonials. So you can see that this is the sign button. These are the directory for the source and destination path. We use these type of USB tokens to sign the PDFs. These contain multiple certificates along with the private key, public key. And we use formats like P.P12 so that it contain the private keys. When you insert the USB token, the software automatically detects all the certificates that are inside it. So you can select the certificates, select the appropriate certificate that you want to sign it, and after selection, it will check for its validity. If it's valid, only then the signing will initiate. And you have to insert the token pin here. You can see you have to insert a token pin and you have to sign it. And after you click on add LTV, the add LTV information will be embedded in the PDF. So there are some features, like we use this for multiple PDF signings at once, because we have to provide multiple degrees and multiple academic testimonials at once. So what we do is we check for the signer's profile at once at the beginning, and we think that all the other PDFs have the same status. Like all the other PDFs have been signed twice by the same two people. So we embed the same signature profile all throughout. This is known as batch signing. Similarly, the LTV information is also taken from the internet only once, and we embed all the PDFs at once. This is all. Any questions?
Now tell me from my side question. Actually, what is the difference between Adobe native signing and your explicit signing? Both are different? Adobe also provides the native signing inside document. You go and make a template and there you can sign.
Yeah, they are basically same.
These are basically same.
Same, yeah. And
Then how are your next question is how you are extending the period of long-term validations?
because we embed the all the information like certificate revocation lists, OSCP responses in the document itself. So when you open the document, the verification is done.
After expiry of
Yeah.
the certificate, suppose you
Yeah,
open the document,
yeah, so the-
somewhere time stamping will be there. or
Yeah,
not?
yeah, timestamping is there.
That
The
you are-
timestamping
you are
itself
eliminating-
is signed by the timestamping authority.
Okay.
That is done in the DSS.
All right, that is there. If time stamping not there, then client's time will be embedded.
Yeah. If timestamp is not there, client stamp will be embedded. But when you connect to the internet, it will automatically update with the
Then after a
timestamp.
long period of time, then the signature is not valid, invalid, the message will come or
Yeah,
not?
it will come. It will come.
Then how it will validate?
It will
For long-term,
because at the time of the signing, the certificate was valid.
okay.
So-
And that's okay. But after the expiry of the certificate, how it validates the,
It has the certificate revocation list at that time. When
then you are taking.
yeah, we will check through that CRL.
Thank you, thank you.
Okay.
Thank you all.
Thank you all. I invite Dr. Balaji Rajendran to honor the session chair, Mr. Shamsuddin Khan. Okay, an announcement. I request the paper presenters to meet Ms. Geetanjali at the reception desk for the kit. Okay. With this, we conclude today's session.
Hello. So today's session has ended, but tomorrow we will be back with two keynote speaker, two invited speaker, few paper presentations, and one panel discussion on post-quantum cryptography. So see you tomorrow. And one more thing, the registration kit, the conference registration kit will be given tomorrow afternoon. So tomorrow's session starts at 10 o'clock. So be present before that so that we can start in time. Thank you. Thank you all. See you tomorrow.